Hi, welcome back. We're up to Lecture 3. In Lecture 3, we'll be talking about variables, distributions, and scales. And as you can tell from the title of the lecture, this lecture is divided into 3 segments. In this first segment, we'll talk about types of variables. It's very important at the outset of the course to understand what type of variable you're dealing with when you're conducting a particular statistical analysis. So we'll be careful here to explicitly define different types of variables. So first, what is a variable? Well, a variable is anything that can take on multiple values, in contrast to a constant that only takes on one value. So comparing variables and constants, you might say, is like comparing apples and gravity. So here's apples and gravity. Apples, the size, the shape, the weight, even the type of apple, those are all variables. There are lots of different types of apples. They take different sizes, different shapes, different weights, and so on. Those are all variable. In contrast, gravity or gravitational force is a constant on Earth. In statistics, it's common to classify variables into 4 distinct kinds. And I'm going to follow suit with that tradition, and the 4 kinds are nominal, ordinal, interval, and ratio. You might think, where did these 4 kinds come from? They come from classic cognitive psychologist S.S. Stevens, and this is a classic paper published in Science in 1946, where he outlined these 4 types of variables or 4 types of measurements. So let's start with the simplest type of variable, a nominal variable. A nominal variable, and it literally means to name types of instances of variables, is to just assign individual cases to categories. So for example, the Coursera students that are out there that are watching Statistics 1, they come from countries all over the world. So your country of origin is a nominal variable. It's just assigning individuals to categories. So country of origin is a nominal variable. It just allows me to distinguish some students from others. So there are some students from Brazil, some students from Argentina, some from Australia, India, the US, and so on. The next type of variable is an ordinal variable. Ordinal variables are used to rank order cases in a data structure. So again, if we think about the countries where all of our students are coming from in this Statistics 1 course on Coursera, I might rank the countries according to population. So some countries like China, India, have much larger populations than smaller countries, say like France, or a really small country like Luxembourg, have smaller populations. And if I just wanted to rank order them in terms of who has the highest population, they get a number 1, who has the second highest population, they get a number 2, then ranking would be an ordinal variable. Interval variables are also used to rank order cases, so we can order cases from top to bottom. But in this case, the distance or interval between each value is equal. That's why it's called an interval variable. So again, sticking with this theme of countries of origin for Coursera students, each country, if we look at the globe, has a longitude and a latitude. And I can compare the longitude and latitude of each country. And the distance from, say, 0 longitude to 100 longitude is the same as the distance from 100 longitude to 200 longitude. They're equal intervals. They're equal spaces. So longitude and latitude, those are equal interval variables. And in case you're not familiar with longitude, latitude, here's an image of the globe. So longitude just refers to sort of east-west where are you on the globe, and latitude just refers to north-south, where are you on the globe. And again, the point of this interval variable is the distance between, say, 0 degrees latitude, which is the equator, which is right here. The distance between 0 degrees latitude and, say, 30 degrees latitude is the same as the distance between 30 degrees latitude and 60 degrees latitude. So this distance is equal to this distance. That's the point of an interval variable, is the intervals between each unit are equal. So we call them equal interval variables. Okay, the final type of variable is a ratio variable. This is the same as interval, but they also have a true 0 point. So what I mean by a true 0 point, so let's take population. When I talked about ranking the different countries, all I was doing is ranking them. I wasn't talking about the actual populations. If I wanted to look at the actual population, population is a ratio variable. And it's a ratio variable because it has a 0 point. So if the population of a country is 0, that's meaningful. That means that humans are extinct in that country, right? So it's a true, what we call a true 0. Another example is age. If your age is 0, you literally have no age. Another good example, and an example we're going to use a lot in the next segment, is temperature. So temperature on the Kelvin scale, we're not used to temperature on the Kelvin scale unless you've taken a lot of chemistry courses. You might be used to that. But temperature on the Kelvin scale is a ratio variable because 0 Kelvin is absolute 0. It means no temperature, it's absolute 0. So temperature on the Kelvin scale is a good example of ratio variable. So in this classic paper by Stevens in 1946, he came up with these 4 distinct categories or types of variables because there are different types of things we can do with these kinds of variables. I know this font is a little fuzzy and hard to see. I purposely cut and paste this table from Stevens 1946 because I think it's an important paper. Everyone should read it. If you can get your hands on Stevens 1946, or maybe we should post it to the website. It's a classic paper for statistics and also a classic paper for cognitive psychology and for psychometrics in general. I won't go through the whole slide. You can look at this at your leisure. The point is that a variable of type, say, nominal, only allows us to do certain things. It only allows me to say, are 2 entities equal or not equal? So are you from the same country or different countries? So if I take 2 students at random from this course and I just know this nominal variable country of origin, all I can do is say, are you from the same country or are you from a different country? I can't say anything about greater than or less than. I can just say, are you from the same or different? That's all nominal variables allow us to do. As you go down this list, you'll see as you go from nominal to ordinal to interval to ratio, you're allowed to ask more and more questions of your variables. So for ordinal, I can ask not only are you the same or different, but I can ask, are you ranked higher or lower? So do you come from the same or different countries? And does your country have a greater than or less than population than the other student? And so on. With interval, I can ask questions about by how much are you different, right? If I just have rank orderings, so if all I know is you come from the country that has the greatest population, and then I know that you come from the country that has the second greatest population, I can't ask, well, what's the difference in population? That's what interval and ratio variables allow us to ask. Just another example, perhaps a little more intuitive, think about the people who are running a race or swimming against each other in a swim meet. you can get first place, second place, third place. Like in the Olympics, you get the gold medal, you get the silver medal, you get the bronze medal. If all I know is the rank ordering, that's the ordinal variable. Just first place, second place, third place. Who got gold, who got silver, who got bronze. If that's all I know, then I can't ask, well, by how much did the winner win? So was it a really close race between first place and second? Or was it just a blowout? So the person who won was way ahead of the person in second. If all I know are the rankings, if all I know are the ordinal variable, then I can't answer that question about distance. But if I have their time, say it's a running race or a swimming competition, if I have time, that's a ratio variable, there's a true zero, then I can ask questions about, well, by how much did the winner come in first place over the second place finisher, and by how much did the second place finisher come ahead of the third place finisher, and so on. So as you go down this list, you're able to ask more detailed questions. And so in statistics and in this course, we're going to strive for variables that give us that interval or ratio scale. We can't always do that, but ideally we'll use interval or ratio variables because they're the richest in terms of information. They allow us to ask the most in-depth questions of our data. So just to quickly preview the variables that we're going to use in this course, in experimental research, I talked about independent variables. So for example, in the polio vaccine trials, the independent variable was the treatment, whether the child received the vaccine or the placebo. That's a nominal variable. They either got vaccine or placebo. Like the memory training experiment. They either got training or they didn't get training. That's just a nominal variable. Subjects are randomly assigned to one of those two conditions. The quasi-independent variables are also an example. So the sports-related concussion, there was concussion, no concussion. Those are just nominal groups. Another good or popular quasi-independent variable is genders, female, male. We'll typically use interval and ratio variables as our dependent variables or as our measured variables in correlational research. So, for example, the rate of polio in a community, like how many kids out of 1,000 acquired polio after the vaccine, that was our dependent variable. Or we could look at score on an intelligence test or score on a personality survey. Those are in the interval ratio type. And finally, it's important to keep track of whether your variables are discrete or continuous. So what I mean by discrete variables are, examples are like the nominal variables. There's discrete categories, separate categories. Whereas continuous variables are like the interval and the ratio type, where there's just a continuum. So we have this scale on, say, like an intelligence test, and it's just a continuum. Ordinal variables are a little tricky. They're technically categories, right? If I only have, say, first, second, and third, gold, silver, bronze, those are like categories, but they're ordered. And in some cases, we might want to take averages of ordinal variables, and then they look more like interval or ratio. So we'll talk more about that later as we get into some actual analyses. So to sum up this segment, the main point is that there are different types of variables that we're going to use throughout the course and that statisticians use to do their research. And it's really important at the outset that you always know what type of variable you're dealing with, because you can only apply certain statistical procedures to variables of certain types. So just remember that there are 4 different types: nominal, ordinal, interval, and ratio. And know that as you go from nominal to ratio, you're allowed to ask more and more interesting questions of your data. And that's the end of this segment.